Tired? Am I keeping you up? All right, so in order to classify them, we first kind of need to know what they are. So let's talk about what they are. And we're going to start by talking about a monomial. So we're going to define what a monomial is, okay? A monomial can be considered a constant. And from 7th grade, you know that a constant is just a number by itself, has no variable. It could be a variable all by itself. Or it could be the product of those two. In which case it wouldn't be a constant anymore, would it be? It would be a coefficient. So like -8. That's a monomial. A. That's a monomial. -8a is also a monomial. 4xy is a monomial. 3x squared y, or x cubed y to the 4th is a monomial, okay? It's a monomial because it's a single term, right? So I'm going to we call it a monomial because it's basically a single term. And you know what a term is, right? Like if you look above, I think it's up there somewhere, there's constants. Like in that coefficient thing, there's 3 terms, right? Oh, yeah, thank you. I'm sure my screen is off for some reason. Oh, there we go. Okay, so it's basically a single term, and those terms can be made up of all kinds of things. They could have exponents in them. They could have variables in them. They could be just a constant all by itself, okay? So then mono is, if we're going to, I'll highlight mono. Do you know what the prefix mono means? 1, right? It means 1. I never know if I pronounce it the right way, but you know, back in the old days when the ladies had their fancy dresses on and they went to the orchestra or the symphony, they had one little like thing. It's like a binocular, except it's not 2, it's 1. They held it up so they could see a monocule or something, I think it's called. So that is what that's called. So then, if we have monomials, then we can have binomials. Okay? And how many wheels are on a bicycle? How many lenses do you look through for a binocular? So the prefix bi means 2. Okay? And so all a binomial is when you take 2 monomials and separate them with an operation sign. So for example, 4a squared plus 3y. That's a binomial because it's not a single term, it has 2 terms, right? Okay? As long as it has like a plus or a minus sign in between it, it's an expression that is made up of 2 monomials, and 2 monomials makes it a binomial, okay? Pretty simple. So what do you think is next? What prefix comes? How many wheels does a tricycle have? 3. What prefix means 3? Yeah, try. Triangle has 3 sides. So a trinomial has 3 terms, and each term is a monomial. So like, whatever, 5a squared minus 2x plus 1, trinomial. It's actually made up of 3 terms that are all monomials, right? Okay? All right. Now, obviously, you can have an expression that has more than 3 terms in it, but there's not really a special name for that, okay? So it's kind of like 2 and 3 have special names, like when we talk about, you know, we can say 4 to the 2nd power, or we can also call it cubed, or squared, sorry. Or we could say 3 to the 3rd power, but we could also call this, so this is squared, this is cubed, But then anytime you go past that 3, is there a special way to say to the 4th power? No. Your only option is to the 4th power, to the 5th power, to the 6th power. So the same thing is going to apply here. There's a special name for 2 terms, for 3 terms, but 4 or more are just going to be considered polynomials. Because, let's go back up here and highlight this word poly. And poly actually means what? Many. And many actually means, we're going to call it in the world of polynomials, 4 or more terms or monomials. Do you ever hear your parents talk about polyester? Like when it's like a fabric from the 60s and 70s that is made up of all these different kinds of fabric, a little bit of rayon, a little bit of cotton, a little bit of this. It's the most scratchy, uncomfortable, like you would know. Some of the old cheerleading shorts are made out of that scratchy polyester stuff. So that's poly, what that means, okay? So what we're going to do is go polynomial. We kind of already wrote it up there. So polynomial just means many, but for these cases, we're going to say it contains 4 or more monomials. So like 4x to the 3rd minus 5a cubed plus 7x minus 1 plus 3y. I mean, it's got 5 terms. Okay? Okay? So that was the first way, and I think it's the easiest thing to start with because you're used to what these prefixes mean. What mono means 1, by 2, try 3. Anything above 3, 4 or more, you're just going to call it a polynomial, okay? Sometimes you'll see it's a polynomial with 5 terms, or polynomial with 8 terms, or polynomial, you know what I mean? So you don't have to just call it a polynomial, and that's just good enough as long as it's under that umbrella there, okay? So next we want to talk about, let's do that. So this is classified. There's 2 ways to classify. Let's do this. I'm going to use by the number of terms. Okay, so there's 2 ways to classify. This is by the number of terms. Second way to classify, you ready? Is by the degree of the exponent. But you don't know what that is yet. So let's talk about what the degree of an exponent is. So, everybody got that? Okay. But before we do that, let's talk about, since we're going to talk about the degree of an exponent. So 2 ways to classify. By the number of terms that it contains and by the degree of that exponent. Okay? The degree of the exponent is about as simple as it can get. And the degree of an exponent is the highest exponent that you see. Okay, the highest exponent that you see. So if I were to go back here and say 4a squared plus 3, the highest exponent that you see is a what? Exponent, yep. 2. Okay, so this is a second degree. Okay, we're going to give you some special names for that in a minute. So actually, I want to do this. So it's the highest exponent that you see. So let's do this in order. Let's go from 0, 1, 2, 3, 4, 5, and what those special names are. All right. So let's talk about this term right here. We're going to do examples here. 8. All right. This is a constant, right? And because it's a constant, it has a degree. Let's do this. Make 2 columns. Name. So, I know what you're thinking. In a constant, doesn't it have an exponent of 1? If it doesn't have a variable, it doesn't have, in this particular example for classifying, it doesn't have an exponent. So this is a constant, and that's what we call it. So it has a degree of 0, and here's why. There's no variable. So that's what we're going to... Okay. How about let's take for x. What's the highest exponent that you see? Think about it. What's the exponent to that x? A 1. So this is a first degree, and first degree has a special name, and it's called linear. We know that, right? We dealt with linear equations for like 2 months straight back in December, right? How many times did you graph y equals 4x plus 2? Right? Linear. So you know, and here's what this bigger picture is getting here. I'm not sure I was ready to talk about this yet, but the degree of the exponent is going to tell you a lot about what it looks like on a graph. So this first degree means that it's linear. It's going to be a straight line. Okay? And that's all you know right now. Like there's a whole nother world out there of shapes on a graph that aren't lines. So let's take like 5x squared. And let's have the exponent be a 2. Let's do. So if the highest exponent you see is a 2, that has a special name. Kind of annoyed by it because it's not what you would think. We call second degrees quadratics. And yeah, and that really makes it sound like 4. You'll see the name for 4. I kind of think they should switch, but there's some reason why they don't. So a second degree, that's the hardest thing that you're going to have to get in your head. It's called a quadratic. Okay? Just to kind of, let's just do this for the heck of it. I'm going to show you, check my window. Let's show you what each of these looks like. So y equals x looks like that, right? Okay. Y equals, so that's linear. So as soon as I change it to x squared, it is now a quadratic. Let's look at what the shape of that is. And I know some of you have seen this. You've seen it on the step before, or the whatever. I remember some of you said, I think Maddie said, there was a big hump there. Okay? So then, here's the cool deal about that. You know that because it's a second degree, you know that's the shape it's going to be. It might be a little narrower, it might be a little wider, it might move around, but that's the shape it's going to be. So when I go to y equals x to the third, and graph it, it's going to be its own special shape. It's going to kind of be one of these halves. So it's like here, here. Okay? So each of these degrees are telling me something. Oh, this is going to look like this on a graph if it's got a 2 as its highest exponent. If it's got a 3 as its highest exponent. Let's see what it would look like if its highest exponent was a 4. So that's really what the degree of these exponents of these things are going to tell us. Okay, there's kind of a little loop there at the bottom. So these are pretty important things that they're telling us, right? Okay, so then let's take 10x to the third power. And if it's got a degree of 3, meaning 3 is its highest exponent, this one's not so weird. It's called a cubic. Pretty straightforward, right? Cubed means 3, volume, right? Okay. We're going to go up to 5. 8x to the 4th. So a 4th degree, you would expect it to be a quadratic, but we call this a quartic. I know.
Oh, sounds like quarter.
Yeah. Which makes you, 4? Quartic. Mm-hmm. Quartic. Yeah. Okay. And then our last one, let's say negative 2x to the 5th. So the 5th power gives you a 5th degree, and we call 5th degrees. Do you remember that little video of that guy, that little kid I showed you on Little Big Shots who was so smart? Yeah. When he started by saying that number, it was 5 sets of zeros out. So what did he call it? He said 536 quintillion. So this is called a quintic. Okay? How do you say 15 in Spanish? Quince. Right? So do you see the similarities with that? Okay? So I want you to kind of take a look at this. If it's a constant, the only name for it is constant, and that means its degree is a 0. Linear, quadratic, cubic, quartic, quintic. Got it? Okay, so now what we need to do is put these two together. Put these words, monomial, binomial, trinomial, polynomial, with one of these words. So you have to have one from each of these lists. You know what I mean? So if I were to ask you to take 4x cubed minus 3a squared. So now we're going to classify by both. Both the number of terms, and so the first thing you're going to do is classify it by degree. The first is going to be the degree, and then the second will be the number of terms. For example, I'm going to call this a cubic binomial. Okay? It's very easy to get this confused because people might see 3 and they might think, oh, trinomial. But that would be if there were 3 terms, right? So it's a cubic, but there's only 2 terms, which is why it's called a binomial, right? So it's very easy to kind of swap those 2 out, but you have to really be careful with that. Let's do another one. That all by itself. So how many terms is there? How many terms are there? 1. So we know it's a monomial. And what degree is it? A 4th degree. So we're going to call it a quartic monomial. I know it's weird. Got it? Let's just do a couple more just so you kind of get the hang of it. So the first thing I would do is figure out the degree. Okay? 8a minus 4. Okay, so what degree is it? 1, and 1 means, think of the 1 as an L. L stands for linear, and how many terms are there? So this is a linear binomial. Yes? We good on this? Okay. How about just this? It's monomial because there's only 1 term, and it's constant. So we're going to call this a, yep. Okay. Then there's always ones like this that can get confusing. It's both. I did them purposely. They're both 3 and 3, right? So the highest degree is a 3, and there's 3 terms. So we're going to call this what? A cubic trinomial. Okay, so now let's go backwards. I want you to give me your own, you can make up your own, quartic binomial. It's harder this way, isn't it? Where you have to go backwards because you really have to think. Quartic binomial. Look at your notes if you need to. So the easiest thing to think of is, okay, binomial means I can only have 2 terms. So you only need 1 plus or 1 minus sign. And the highest degree that you need to show is an exponent of what? What's quartic? 4. So who's got one that matches? Hannah.
4 minus 3a to the 4th.
Okay. 4 minus 3a to the 4th. 2 terms. Quartic. Good. Anybody else got another one? 10x to the 4th plus 9. Okay, you guys got it. Got it? Okay, got one more thing to show you, and then we're done. Okay, it's called standard form. And I know, you're like, no, not that again. It has nothing to do with the standard form that we learned about graphing, okay? So standard form of a polynomial is different from standard form of an equation. So standard form for a polynomial is really, really easy. It just means take those terms and move them around until you get it in order from the highest exponent down to the lowest. And then constants are always at the end. Yeah. So I will show you an example of a polynomial written perfectly in standard form. Like 4x to the 5th minus 2x to the 4th plus 3x to the 3rd minus x squared plus 1. Okay? 5, 4, 3, 2, none. Well, actually, I should put one more in there. I was thinking one because I want to put right. Okay? Do you see why I had to add that? Because I was missing that first, because this really is a 1. And it's so tricky because this has a degree of 0, constants do, but you don't want to say it has an exponent of 0. Because what are you telling me if it has an exponent of 0? That it's 1, and it's not. It's -3. So be very careful with that, okay? So basically, this is the last part of it. You're going to get them all scrambled up on today's sheet. So on today's sheet, that's already actually in standard form, right? That one's good. Is this in standard form? What needs to happen? These two need to switch. So the first thing is going to ask you to put each polynomial in standard form by their degree, and then name each polynomial by the degree and the number of terms. So you're going to switch these two, and then you're going to say that because it's a 3rd degree, the special name for 3rd degree is cubic. And how many terms are there? 4. Is there a special name for 4? No. 4 or more just means it's a polynomial. So you're going to say cubic polynomial. Sometimes you'll hear it say cubic polynomial with 4 terms. Or cubic polynomial with 8 terms. You don't have to write the number of terms. I know that you know how many terms there are. Okay? So the only other thing I need to say is this, and then we'll be done. So like 5 minus 2x cubed plus 4x plus 3x squared. Okay? When you pick these things up and move them around, you know that the sign in front of it has got to go with it, right? If I'm going to move that, I better move that negative with it. Okay, so just let's put a negative here, just to kind of show you. So what has to go first is the negative 2x to the 2nd, or 3rd. then this, then the 4x, and then the negative 5. So you know that. Just to make sure when you move those around that it's with, it stays with the